welcome to Main and 5W channel for yet another very interesting session about natural language processing. There are several questions from the workshop for me to talk about NLP. So in this discussion, we'll give you a comprehensive overview about NLP, and then later we get into specifics in terms of how to implement NLP using the different platforms, different tools, and how do we really use it for a practical use case. Okay, so this one video could help you to really get an overall feel about what is NLP. Okay, so NLP is really felt in social media while they're trying to monitor what you're talking, maybe what you're writing into Facebook, what you're writing into a lot of the Instagram, blah blah blah. So social media monitoring uses a lot of NLPs, which we want to really look at, and what people are feeling. Like, is it a good feeling? Is there anything getting viral? So sentiment analysis also is done through NLP. Whenever you get a mail, to filter based on the content, spam filtering happens through NLP. Email classification based on the mail, chatbots. Very recently, the algorithmic trading, which is happening for the last 1-2 years in terms of the stock analysis, which can be done automatically. NLP is also used. Okay, so NLP has got a lot of practical applications. So let's define what is NLP, and then we look at various perspectives. So NLP is a computer-aided text analysis of human language. The goal is to enable machines to understand human language and extracts meaning from text. It's a field of study which falls under the category of machine learning and more specifically computational linguistics. An example could be Natural Language Toolkit is a Python module that provides a variety of functionality that will aid us in processing the text. So these are pretty basic things which you should all know. Now we all know, like a lot of text we write, we are quite used to be writing something and then reading something. Now if you want that to get automated, somebody reading the text and trying to comprehend meaning from what you have written, what is the meaning of the sentence, if somebody writes something, does it have a good sentiment, bad sentiment, in the content of an email, if it is good, bad, is it coming from a recipient or coming from a receiver, sender who is actually having a fictitious name? So these are all can be analyzed by using NLP. So as I told, there's always common sense which works. Basically, there is a kind of an we have a set of data with us, and then there is an input set of data coming in. We'll be able to pull that data, compare, contrast, and then really tell what's happening. But this can get automated by using the NLP. Okay. Now let's see, before we go there, some of the practical application you can see is heavily used in search engines. It is used in site recommendations, spam filtering. It's used in knowledge base, expert system, automated customer support system, banking, fraud detection, and consumer behavior analysis. This is some of the places we can see NLP looking at. Now let's see the various dimensions of an NLP. Okay, so we just first start with basically looking at what the Wikipedia is talking about. As I repeatedly tell students, while you are trying to read any subject, you either have to read the Bible of that particular subject, maybe by buying an author of a book who has written it, or go to Wikipedia and have a generic view. It is always recommended best practice because it is not getting very tool specific or very specific to a language. Get a neutral view about the subject. Okay. So I do two things for that. One, I try to go and see, for example, if I have to read something about hardware, I try to see some gurus, some good books where like Vinel Roche, I read some books and then look at a lot of generic information before I jump into a specific Intel processor or trying to talk about something which is GPU specific, blah, blah, blah. Okay, now let's get to the topic. NLP, as per the Wikipedia, is a subfield of linguistics. We all need to understand we are talking about a language, we are talking about writing something. You might be writing in English, you might be writing in French, Spanish, you might write in any of the language, right? So we are not talking linguistics only from English perspective. So there is some language and something has to interpret the language. That's where the NLP. So natural language processing. Okay, so it's related to something to do with arts or something to do with language. Okay, that's linguistics. Second, computer science. Computer science is because you need a language to really read it, blah blah blah. And then AI. Okay, concerned with the interaction between computers and human language. In particular, how the program computer process and analyze large amount of natural language data. What is natural language data? An email, what you're writing, or you go to a social media and type to comment, okay, and then or you're branding something. So something which is coming naturally out of it. How do you interpret that, read that text, and then make some meaning, and then try to process? Okay, that's more tougher. The computer capable of understanding the contents of a document, including the contextual nuance of the language with them. The technology can accurately extract information, insights contained in the document, as well as categorize and organize the document themselves. Okay, there are a lot of challenges in the NLP frequently, which involve speech recognition, natural language understanding, and natural language generation. So this is some of the look at. So let's see some brief history about it. So you can see that symbolic NLPs, this is good thing to read for all of you, because the premise of symbolic was summarized by John Searle's Chinese room experiment. Given a collection of rules like a Chinese phrase book with question and matching answer, the computer can emulate NLP by applying those rules to the data it confronted with. Okay, so this happened in, there was an experiment done in 1950. We're not going deeper into it, you can go through yourself. 1960, then there was something happening on 1970, and then 1980s you could see that it was just evolving into a lot more algorithm like generative grammar, less algorithm, and then there was rhetorical structural theory, and then there were development of chatterbots with Racter and Jabberwocky. Okay, so there are a lot of ways this got evolved. No, this was a symbolic NLP between 1950s to 1990s. Now you might ask me, why should I know this? That's left to the candidate. So if you want to jump into something without knowing where it came from, the origin, it may not take more than an hour for you to really know the history. It really makes you more sharper in computing. Okay. Then there was statistical NLP between 1990 to 2010. So if you really see in 2000s, a lot of web happened in 2000s. There's a lot of raw data which came in 1990s. Okay, there was increasingly focus on unsupervised and semi-supervised learning algorithms. So such algorithm can learn from data. So that is where the world was. Okay, and then it became a neural NLP in the recent times. So we are here in the neural NLP. So there were three phases of NLP, from symbolic to statistical to neural. In neural NLP, we're looking at representation learning, deep neural networks style machine learning methods. Okay, and then we start using that. Okay, what are the methods we use in NLPs? Basically use rules, statistics, and neural networks. Okay, these are some things which we use, right? So if you have programmed this, you understand what it means. Okay, the learning procedures used during machine learning automatically focus on the most common cases, whereas then writing rules by hand is often not all obvious where the effort could be directed. So this is where the NLP methods got started. So what are the various methods? You have statistical methods, you have neural networks, and there are a lot of common NLP tasks. For example, text and speech processing. Like you can have an optical character recognition. Given an image representing printed text, determine the corresponding text. That can be done in OCR. You could have seen this now today's while you're creating an account or something like that. It can ask you a lot of interesting questions and automatically convert it, right? Then you can have speech recognition. Given a sound clip of a person or a people speaking, determine the textual representation of the speech. This is opposite of text to speech, one of the extremely difficult problems termed as AI complete. Okay. So in natural speech, there are hardly any pauses between successive words, and thus speech segmentation is necessary subtask of a speech recognition. Then you have speech segmentation, text to speech, and then there is a word segmentation, which is tokenization. So text and speech processing is also one segment of your NLP task, and then there is morphological analysis, which is very interesting. Example is lemmatization, where task of removing inflection endings only and to return the base dictionary form of a word, which is also known as lemma. Okay, and then there is morphological segmentation, separate the words into individual morphemes and identify the class of the morphemes, right? And then there is a part of speech tagging. Given a sentence, determine the part of speech for each word. Many words, especially common ones, can serve as a multiple part of. For example, book can be a noun. When you tell a book on the table, it can be a verb, which to book a flight. Okay, So like that, you'll have to also understand. So it's not pretty easy. So imagine all of us are attending an English class. There is a lot of things taught to us, and then you start writing, right? Now, if you want to make an intelligent brain which can scan what you're writing and scan the knowledge of a teacher, right? So knowledge of a teacher is there in an automated system, and then it is able to read that knowledge and then convert. Then there is an action on it, what to do, okay, which may not happen in a class because you might write an exam there. Here you're telling it to do some tasks, okay? That is an automation we are talking about, right? So similarly, you have syntactical analysis like grammar induction, generate a formal grammar that describes the language syntax. You can break the sentence, given a chunk of text, find the sentence boundaries, then you can parse the given sentence. Okay, so all this can be done through a syntactical analysis. Similarly, you can do lexical semantics, right? What is the computational meaning of individual words in context? You can do distributional semantic. How can we learn semantic representation from data? You can have named entity recognition. You can do sentiment analysis. Okay, extract subjective information usually from a set of documents, maybe an online review, determine polarity between specific objects. Useful for identifying trends of public opinion in social media for marketing. You can do terminology extraction, word sense disambiguation. You can do relational semantics. Relational extraction is given a chunk of text, identify the relation between the named entity. You can do semantic parsing, semantic role labeling. Then you can also do something called discourse. Basically, an example could be confidence ratio. Given a sentence or a large chunk of data, determine which words refer to the same objects. You can also do anaphora resolution, a specific example of task concerned with matching up pronouns with the nouns or names to which they refer to. Okay, and you can do discourse analysis by doing implicit semantic role labeling, recognizing textual entertainment, and also do topic segmentation and recognition. Okay, what are some of the higher level NLP application? You can do automatic summarization, book generation, dialogue management, document AI, machine translation, natural language generation, natural language understanding. You can also do something called question answering. Okay, all these are possible applications. And if you really see from a cognition and NLP, cognition, what is cognition? It refers to the mental action or process of acquiring knowledge and understanding the through thought, experiences, and the senses. So cognitive science is the interdisciplinary scientific study of the mind and its process, right? Now cognitive linguistics is an interdisciplinary branch of linguistics combining knowledge and research from both psychology and linguistics. So if you see George Lakoff, if you're not read, it offers a methodology to build NLP algorithm through the perspective of the cognitive science along with the finding of cognitive linguistics. So this is a very important area of trying to relate the NLP with something what we talk about, the way the human is thinking, experiencing and using his senses. Okay, and he has defined a formula, basically an RMM token which is equal to, I think you can see that formula. Let's take an example. Some of the meanings in English, the word big, when used as a comparative, that's a big tree. A likely inference of the intent of the author is that the author is using the word big to imply a statement of tree being physically large in comparison to other trees of the author's experience. So you can actually go into that level of deep by using this formula. Okay, so that is up in the Wikipedia. So it's a very nice combination of telling you from the history to the methods, rule, statistics, neural networks. What are some of the common NLP tasks? Then talks about cognition, cognitive computing, and NLP. And then it talks about some of your practical applications also. Okay. Now let's see the second dimensions of this is to see it from a what tool will you have? Suppose theoretically you've gone through Wikipedia, you've read 2-3 books, you've seen a complete YouTube channel, you did a course, blah blah blah. You will finally come to Nltk 3.5. So we'll do a separate, I am doing workshops on this, but we will do a separate video on a hands-on with the Nltk. But Nltk is a leading platform for building Python program to work with the human language data. Okay, it provides easy to use interfaces to over 50 corpora and lexical resources such as WordNet, along with a suite of text processing libraries for classification, tokenization, stemming, tagging, parsing, semantic reasoning, wrappers for industrial strength NLP libraries. It also has a very active discussion forum. Okay, so you can really see a lot of hands-on lab there, and you can download this particular book and you can get started. So the reason why I showed you this is, if after you read, if you want to do a self-learning about implementing it, Nltk could be a good way. It has got how to install it, how to use the data what is given. You can test writing program. For advanced workshops, you might really reach a mentor or something who can help you to do a practical use case. Okay, so we have seen three dimensions. We defined what is Nltk. We saw a Wikipedia view, which is the generic view of Nltk from a historical to the current, and we just saw a toolkit, which is natural language toolkit Nltk, which is used for from Python to actually implement the Nltk. Now let's see dimensions from how do companies use it. Like, let's see, like there are a lot of companies which are implementing. Suppose you join a consulting company and you join a product companies. How do they look at NLP? Okay, so let's see how first Google Cloud looks at it. Okay, now you have something from Google Cloud as a platform itself, right? So if you just log into GCP, you can get started for free. I'm not sure whether all of you have got a trial edition. Get a trial edition for GCP, AWS, and Microsoft Azure. You can try between all the three or try one of them to implement whatever I'm discussing in this channel. Okay, so if you want to go to natural language, you can actually look at like natural language. There is an API from Google Cloud. There's something called AutoML natural language. You can derive insights from unstructured text using Google machine learning. So what Google Cloud provides you is it provides you an insightful text analysis. So you should imagine how the cloud provider will look at is they could have implemented some kind of form of NLP, and its infrastructure will be self-managed or it is automatically, it's a managed service. A user can use that, either call that API or you can give some input. It can be very declarative and you can get the results. So that's where the power of cloud is. Like, no, you spend less time. So that is the reason I don't want you to start with Google Cloud. When you're thinking NLP, you should really read a lot of research papers or Wikipedia and go very deep into the subject, because the moment you come to the cloud, we are talking about automation, autonomous. Okay, and so it's going to be pretty fast for you from a business. Your understanding is low when things are pretty fast, because you may not really know what's working behind the scenes. So if you practice that and come here, it's two in one. One, you know what you're doing. Number two, you don't have to do that because it's already automated. So you can focus on the customer's business case. Okay. So what Google talks about is it's a natural language, uses machine learning to reveal the structure and meaning of text. You can extract information about people, places, and events, and better understanding social media sentiment and customer conversations. Natural language enables to analyze text, also integrate with your document storage on the cloud storage. What it provides you is it's providing you an AutoML natural language. You can train your own high quality machine learning custom model to classify, extract, and detect sentiment with minimum effort and machine learning using the AutoML technology. You can use the AutoML natural language UI to upload your training data and test your custom model without a single line of code. That's pretty interesting. Second, it provides you a natural language API. The powerful pre-trained model of natural language API empowers developers to easily apply natural language understanding to their application with features including sentiment analysis, entity sentiment analysis, content classification, and syntax analysis. It also provides you a healthcare natural language AI, which is specifically industry driven kind of thing. We all understand Google or Amazon, including Microsoft to a level or more, a platform. They're quite strong on the platform, which is IaaS and PaaS. Unlike Oracle Cloud or SAP Cloud or Salesforce, which are pretty strong from a domain of the application. So they're more focused on the app side, okay? But they still have platforms and infra, but they are more focused on the SaaS side. So nowadays what has happened, the trend is like even the platform provider coming out with something very industry specific, so that they understood like that's what connects very closely to the customer. Okay, so healthcare natural language AI, it should be one of those kind of initiative. You can gain real-time analysis of the insights stored in unstructured medical text. Health natural language API allows distill machine readable medical insight from medical documents, while AutoML entity extracts for healthcare makes it simple to build custom knowledge models for healthcare and life science app. Okay, you You can also see, you can see a demo of your app. We will see a demo in the subsequent session, and it also talks about how it works. So you can actually upload your documents. It could be text file, PDF, and you can train your custom models, and then you can evaluate. Okay. Benefits is it gets insight from customer, multimedia, multilingual support. You can have extract key document entities, receipt and invoice understanding, content classification, graphs, best of the Google's deep learning models. So here there's a comparison about which NLP is better in Google. So I'm leaving this for you to just go through. And there are some customers who are using it. There's also some video there. Okay. Now, after going through Google, if you really switch over to Microsoft, what it does, so Microsoft Research does a lot of work on this particular area. If you really see what a processing group on performing efficient process text and to make their information accessible to computer application. So they do a lot of work here. And interestingly, when you go through the Azure site, they also have an NLP kind of module there. So interesting what happens in Microsoft Research Lab. I did work with Microsoft for a long time. So like there are a lot of research work from here which moves into the production platform, which could be Microsoft Azure or something else, right? So NLP is seen as a lot of research work happening in Microsoft. There are components of it there in the Azure cloud. So, and if you really switch over to Amazon, they come with something called Amazon Comprehend. Okay, discover insight and relationship in text. So you can see that three vendors, three OEMs looking at NLP. If you similarly go to Oracle or Salesforce, or if you go to any of the provider, they will have some components or a product which can really give you this NLP. Okay, is an NLP service that uses machine learning to find insights and relationships in text. It is no machine learning experience required. There's a treasure trove of potential sitting in unstructured data, customer emails, support tickets, product reviews, social media. So you can see that it really provides the same benefit how it works. If you see how it works is, again, like GCP, you can really get your inputs. The comprehend will do the job here instead of your auto ML. And then it gives you a document classification as entity, sentiment, key phrases, syntax, language. So you need to know there is an automation here. So when you're writing in Python, which I introduced you to the toolkit, you might have to write the code. Here you might see some kind of automation. There are a lot of use cases here. View of customer analytics, okay, more accurate search, knowledge management discovery, classify support tickets for better issue handling, perform medical cohort analysis. Okay, a lot of customers are also using it. Okay, so we saw now one dimension, which is the definition, second on Wikipedia. Then we saw a toolkit from Python. Then we saw the OEM's angle to it, which is Google Cloud, Azure, and Amazon. So when you jump into these topics, you should read in the same order so that in 6 months you really know this subject very deeply. Okay, now let's see how does a consulting company looks at it. Now this is very interesting because OEM companies give you a product, but consulting companies are going to go to a customer and tell, we have a practice. Now, even a services company, maybe you're talking about Accenture or HP or TCS of the world or Infosys of the world. So what do? They're going to tell customers about a practice, right? They have an NLP practice by which they will tell that they either there will be cross OEMs. Okay, they'll be looking at customers' business, build a consulting model to them, like we will do a study and try to understand the requirement, then suggest the proper tools, draw an architecture, and then tell it's good to use Google Cloud for this. You have to customize these things with NLTK, and then you might want to use Amazon's for this part of it, blah blah blah. Okay. So what does so I'm just taking an example randomly with Accenture. You can really pick anything like PwC or ENY. So whatever sites, it looks pretty similar and with some differentiation or USP based on your experience they have from the customer centers. Okay, so what the way the Accenture site tells us publicly is natural language processing consulting and implement is tapped into unstructured data, text, voice, audio, images, video to enhance enterprise insights, discovery, analytics, gain better insights of the data. So NLP is being integrated into our daily life with virtual assistants like Siri, Alexa, Google Home. In the enterprise world, NLP has become essential for business to gain a competitive edge. Valuable insight hidden in constructs like text, email, social media, videos, customer reviews, report, or the game changes. Okay, as a search and content analytical practice. Now you need to understand this. So, what is a practice? So, for example, Accenture might have 100 professionals who are specialized in NLP, who are good to go to a customer, try to understand the needs and deliver projects. Okay, so that is very important. We'll focus on delivering natural language consulting and implementation to help enterprise leverage the unstructured data. So that needs some, so that they'll get into a classical software development life cycle or an agile model or a scrum model. We discussed DevOps, all these parts of it. Okay, and you can see that they also have example of the applications they could really consult as question answer systems, intelligent doc. They'll actually build it for you, right? Business chatbots. Now you should know the difference between the OEMs and them. While they're building this, Accenture is building it, or HP is building it, or TCS is building it. They might select any of the products what I spoke about before, like they might go into a Google platform or a Azure platform or an Amazon platform, or if you take an example, if it is a SaaS like a Salesforce or something like as a CRM from Oracle. Now here the integration is slightly different into this NLP, because they already have a footprint of these applications. They might use a different platform or customize something. Okay, if it is purely an application, they might use these are some of the applications. What is a job role of a service or consulting company? They might just do an analysis, they might do a design, they might do an architecture, they do implementation of these systems, what's been stated here. Okay, and they also talk about the name of the consultants who really do this job, like a strategic consulting, implementation, support, content acquisitions, enrichment. Okay, and there's a new R&D initiative for scalable. So they also have a research and development team which is trying to experiment with a lot of things. There's a user interface development team, and then there is a machine learning group. Now you understand. You will not see this part in OEM unless they have a consulting practice. Okay, so they will typically focus on building the product. Now, Accenture or PwC or EY will be more focused to consult with these professionals into the customer base. They may go along with an OEM or not. Okay, so common language, natural processing, like what they do is also being listed here, like raw language processing, text mining, statistical language processing, and they do some innovations also with the end customers, right? And search and content analysis, and there are some kind of people who they also put across. Okay, so that's exactly I want to speak about in this topic. I think this must have been very useful for you. You can please subscribe to the channel and like this video, because this is your whatever I'm covering in this channel, it will be a starting point. Now if you're already in the subject, you know something, still you can revisit this video to get a comprehensive view. How do you study a subject? It doesn't change between any topics, right? So first do understand what that topic is about, ask question, ask why you're learning this topic, then get into Wikipedias or master books. I call for every subject there is master books available. Go through them. Then you try to see what is an OEM doing on analyze products generically. Then look at what a consulting and services angle to that is, and then look at a project. Okay, then you know what you're learning this for. Okay, so then there's a job which will either come from an OEM or coming from a consulting or a services company, and that's what you're going to apply for. So if you're not clear on that, you just waste your time doing a lot of things and finally don't know what to do with that. Okay, so thanks for watching. See you in the next video.